This is the second recording, starting with where we had a separation of these ribs. Now we have a separation of these ribs. So let's edit the definition of that extrusion. We have to bring it deeper down in there. So if I edit the definition here, alright, should we just make a line straight across here, or should we use edge? Let's use edge, because if the draft ever changes, it's going to change with it. So I'm going to delete this reference that's not being used, and I'm going to use edge on these. And that means that this needs to be tangent to this, or this coincident with this. So let's go ahead and make these coincident. Point on entity. And that's mirrored about or symmetric. And then let's go ahead and use edge on this one. Oh, what was wrong with it?
I believe you did this set of ribs before the previous set, so you can't use the previous set as a reference.
Look at that. There's my problem. It's not a closed entity, so I'm just going to sketch a line from where that touches straight across, because this rib can go inside that material and it's still okay. Alright, looks like it's going to make. I can't make it dependent on anything. I can't make it on anything. Okay. So you're saying that it's dependent on what?
Well, earlier some drafts were highlighted red. Like if you get out of this.
They're down here.
Down there,
Right. That's after that, though.
yeah, so like I'm not sure it's saying that it's messing up with this.
These are messing up with this, but this is messing up from something else. Right here. Is this sketch reference any good anymore?
No, because we already applied draft to it.
That's right. So if I go to wireframe, we didn't apply draft to it.
We did, but the draft is further down the
Okay, so it still shouldn't hurt us right now, should it? I don't think it still should hurt us right now. Let's go in here and look at this. This is the problem. You see that overlap? It's got multiple boundaries. So let's make this tangent. So, do I need this to be 32?
Yes.
Do I need the 10 dimension? Yes.
Oh, well, no, we need to get rid of the coincidence restraint on the other side.
Okay. So, how do we get rid of that? We're going to hover over this. Right click until you get that vertical constraint. Delete it. And let's make this tangent.
No, we made the other side. The left side is where we did the original coincident restraint.
Okay. The theory is the left side needs the coincident constraint. But it doesn't want to be symmetric with these two dimensions on here. Because this can't be a full radius with tangency here and be tangent down here, and this be a certain distance off here. We're going to take this 32 off. Now it can be tangent. Do you really think that 32 radius is necessary if it's tangent?
No.
Okay. So let's go ahead and finish it. That one made. All we need it to be is a round. And it needs to be tangent down here, and it needs to be tangent up here so it's smooth. Okay, let's bring in this round. Now the draft's made. So what else did we drafted this inside and outside. These. Do we need to split draft this curved surface right on top, don't we? It's perpendicular to, let me see, right is our splitting plane. So we're not going to have a problem with that. You guys want it? Let's do a draft check real quick. Let's do solid geometry. And I know the holes aren't drafted, but let's use that right datum plane. It's looking pretty good, but we need this flat surface drafted, don't we? If we don't put an insert in there and pull it out, we're going to put an insert in there and pull it out, so that has to be flat. Because that insert is going to shut off on that tool right there and pull that pin out of the top. So that's going to be flat. Anything that's perpendicular to this without a shut off right here would have to be pulled. But since we have a hole that's going to be pulled this way, there's going to be steel up against this, and it can pull that pin out. That way we still have a flat surface for whatever's going to mate to that. Does that make sense to you guys? When I get finished with this, I'll make a tool, okay? And then we can look at it. What about this surface?
Same concept as the top.
Yeah, same concept. It's going to have the pins in there. It's going to pull out. So this is going to be a AB pull with two slides pulling out each side. I'm going to resume this pattern of holes, and now we can put draft in it. So draft the surfaces. So if I select this and I go to details and I go to add, I could say this is my anchor surface, and I could select these loop surfaces. Anchor loop, anchor loop, or you can select all of them. Now I can select the outside surfaces as well if I select this, but I don't really need that. Okay? This is our draft. It's getting smaller. So what did we say that we wanted to be? It's getting larger, I'm sorry. What did we say that we wanted the hole? We want the hole at the mating edge to the next part to stay fixed, right? Because that's going to have a certain clearance to the screw. And we want this to get smaller from that direction, right? Or larger. If the screws are coming down from the top, it's going to be smaller. It's going to be larger this direction. But we can't pull the pin out now. So we're going to leave this constant. But what's going to happen? These are drafted surfaces.
Increase the size of the bottom hole, or the bottom circle.
Just flip it. Bottom side of the hole is remaining constant. This is getting smaller this way. That's what we want. Does that make sense? For the pins?
I wouldn't want. I wouldn't want my part to work that way, but
That's right.
I don't see how.
That's right. You can make it larger and this remain constant.
Yeah.
But we can't pull it out that way.
Right.
We want it to be larger where the screw goes in and get tighter down here. So where does our hinge want to be? It wants to be at our constant, right? Yeah, we have to put it on the other side. So what we're going to do, we're going to go back in before this draft. And we're going to put a plane right here. And we're going to split about that plane. So I'm going to drag my insert mode up here. And I'm going to put a plane, I'm going to make a plane that's through this offset 0. And that's going to be my split plane. That's going to be my draft plane for those pins. It's going to get bigger at the top, keep constant at the bottom. So let's look at it. put our draft in. Oh, these are my references, I guess. It's individual references. What was that plane that we went to, right?
Face the right plane with the top at the top.
Good grief. Okay, we're going to say look at this plane with the top as being the right plane. So if I could grab this right. Datum plane. There we go. Now if I save this view, I'm going to save this as pull direction. Okay, so we've got those. Our draft hinge is datum 2, right? Pull direction is datum 2, and it's 1 degree. Is that going to work? It's getting smaller at the bottom. The top is remaining constant. We can't do that. It's got to get bigger at the bottom, right? What's our problem here?
We put the holes on the wrong side.
It'd be expensive to do it that way because you'd need 2 slides coming
In the middle of the
in the middle of the tool.
Let's go back to our draft hinge and use this again. Oh shoot. Draft hinge here.
You go to like options or properties to change which hole
Oh!
stays constant.
It's bigger at the top. It's smaller at the top. Bigger at the top. Smaller at the top.
And you go into options or properties.
Nope, that's just a name. How are we going to do it?
Well, you gotta get bigger at the bottom.
Got to get bigger at the bottom, and we want the top to remain constant. Draft. Let's select these two. We got to get bigger at the top, at the bottom. So let's go here. And so I just have one edge. If I go rule based, it'll do the tangent or complete loop.
Yeah, this is right. Yeah, that's right. It's staying put at the top and getting bigger at the bottom. That's right now.
It is. But I want the bottom to remain constant.
Now you want the top.
And this, no, I want the bottom to remain constant because I want lead in for my screw. So my tangent hinge is going to be this.
The top's getting smaller. Well, that's the only way you can do it. That's what we want. What are the two top gets smaller, or the bottom gets bigger. So which one do we want? You can just do it the original way to where you have the data plane on the bottom then.
Yep.
And the top gets smaller, the bottom gets bigger. That's the only 2 ways to do it.
Yep. If we want the bottom to remain constant,
Then the top has to get
That's right.
So which one's more important, retaining the aspect ratio at the bottom or the top?
After you get finished with this draft, you need to look at the clearance in the hole. You may have to increase the size of the hole with the draft on there. Does that make sense? If you want to retain the clearance between the bottom, which is the largest, or the top, which is the smallest, we want to remain constant at the top, which is the smallest, for the clearance. That's our worst case, right? Okay. So let's take off all these tangent chains, and let's just use the bottom of this part and make this simple again. And let's grab all the rest of these surfaces.
We also said in our notes that we only needed a half degree on these holes.
1/2 degree, so that's going to help us. Good. So what we have to look at is what is the smallest diameter of this, and make sure that we have that the proper clearance. So we would increase the size of the hole to get the clearance from the screw that we want in the clearance hole. So what do you think the difference is in these two? Analysis, measure, diameter of this one, 7.99. Let's do the
You're currently stuck on surfaces, saying that you can only select surfaces in the top right corner.
Filter.
Yeah.
Okay, I
wasn't
see.
Just saying surfaces.
It's only going to let me do that for diameter. So we can measure, since we have 2 points, 2 surfaces on each, we can measure distance from point to point. 7.8. What was the other one? 7.99 or something? And 8.
799 was probably the average of the two.
So it was 7.8. So it's 0.2 difference of 1 millimeter. 1/10 of a mil. What is 1 millimeter?
1/22 of an inch.
That's 1/4. It's 40 thousandths. 0.0393736. So if you take 1/10 of that, that's 3 thousandths difference. 4 thousandths difference, right?
And we had that much intolerance on that sort of,
Yep.
didn't we?
That was on the diameter of the boss, how much tolerance was going to be on the screw. That's right. So if we go to the high side, we might be in trouble. So we would go back and change the diameter by the difference in these two things, which would be 1/10 of a millimeter, 4 thousandth. Right? So that'd be 8.1, right? All right, so where are these holes? If I edit the definition,
But doesn't that accomplish the same thing as making it bigger at the bottom anyway? Inching it from the top of the hole to the bottom.
I thought we were doing that already and it wasn't doing what we wanted though.
We were maintaining aspect ratio at the bottom and then made the top smaller.
Let's go back to our planes. Let's change this to back here. Oh, that's an angle plane. We can't do that. It's 8.1. If we change this back to 8, it's just getting bigger at the bottom. We just wanted this to be bigger at the top for lead-in, but we're not going to be able to have it. We just need this to be 8 because that was keeping our clearance to our hole. So let's go back and change that hole again. So we were doing the right thing in the first place.
Could we, if the problem is a lead-in, could we create a small chamfer?
Yes, absolutely. That's normally the way you want your draft. It's pulled this way because you want to put those in there, but you don't want to do that with all these features inside here. That hole is here. We need to drop this one too, right? Where are we going to drop this one from?
The top.
The top, and let it get smaller. It's better to have interference in a plastite screw than have looseness. So I'm going to put in a draft. These surfaces. And if I go to references, details, let's just add. Draft hinge is here. And what is the length of that? $14 millimeters. That's a 1/2 inch. So let's give it a 1/2 degree of draft. And sometimes when you need an absolute, you might revolve something. Okay. That's going to be almost negligible. I'm going to save this again. Let's see what these rounds do. Oh!
Failed on the first one.
It's not got complete rounds now that we have split draft.
It's not going all the way to the
What we're looking for is a failed edge.
Found them.
All of them. Dang it. These were the ones, right?
No. No, that's right, that's right.
Woohoo! Save. Let's go to the next one. Our next couple. Round 3 made.
Why did we have some of those but not? Why do we not have a symmetrical set of edges?
Just didn't grab the whole loop. Hopefully. We need these hinges too, don't we? Just smooth it out.
As well as on the other side.
Here, too.
Yes, but also on the,
Oh. Yep. Oh. That one's already made. But I need to put it on that one. And this one. It's just smoothing it out. Oh man.